Auzu billahi minash shaitanir rajim. Bismillahir rahmanir rahim. Dear students, Assalamu alaikum. Today we are going to start a new topic relating to space vectors. In this topic we will try to search out, we will learn about what are the scalars and the vectors, and how are these used to represent different quantities in the space. We will learn how the position of a point in a space in Cartesian coordinates is defined, and how a vector is represented. Similarly, we will also see that how different algebraic operations are performed over these vectors, means how are they added and subtracted, and what is their scalar product, what is their vector product, how is the magnitude of a distance vector measured, means how can we measure the distance between the two vector quantities, and we will see it through some examples. Similarly, we will also learn to calculate the angles from the respective axes measured for the different vectors, and we'll see a few examples. Now, first of all, we will see what are the vectors and what are the scalars. Quantities that require the magnitude and the direction for their complete representations are called the vector quantities. For example, velocity, acceleration, etc. While the quantities that require only magnitude for their entire or complete representation are called the scalar quantities. For example, mass, time, etc. Now let's see what are the scalars and the vectors. Vectors are actually the quantities that require magnitude and direction for their complete representation. For example, velocity, acceleration, etc. While on the other side, scalars are the quantities that require only magnitude for their complete representation. For example, mass, time, etc. We can locate the position of a point. Let's say for this example, this is a point P XYZ in the Cartesian coordinates with the help of position vector. So position vector means the position of a point in a plane of space with respect to its origin. So this point can be located anywhere in the space from the origin with the help of these values x, y and z, which are actually the different values against the x, y and z axis. If the point P, x, y, z is a point in the space, the vector r from the origin O to P is called, from the vector r from O, position O to this P is called the position vector, and it can be defined as the sum of all values along their x, y and z axis. For example, the position r can be xi plus yj plus zk. It means if the position of a point is x, y and z, then it can be, then the it can be written as xi plus yj plus zk, and its magnitude, the vector magnitude, can be represented, can be calculated by taking its mod value, and the root mod is r is equal to r into r dot r scalar product, and then under root. So x square plus y square plus z square whole over under root is the magnitude of this vector. If you see that this is r, r can be, r is basically O to P. So it is basically the sum of OB, O and B. This is the value of O and this is B from this point, and then A and B along y-axis, and then B and P along z-axis. That is why x, y and z. So it is the sum of all the values along their respective x, y and z axis, and hence the position of a vector can be written as xi plus yj plus zk. A vector can be multiplied with some constant. Let's say we say that a k into a means if the vector is a1j plus a2j plus a3k, then k will be multiplied with each component inside the vector. For example, k will be multiplied by k a1j, k a2j and k a3j for any scalar. Similarly, two vectors can be equal only if each component along x-axis is equal to respective component on the x-axis of the other vector, and each component along y-axis is equal to respective component of the vector of the other vector on the y-axis, and the third component, that is normally along the z-axis, should be equal in both vectors. So a vector A would be equal to B only if A1 is equal to B1, A2 is equal to B2 and A3 is equal to B3. These 1, 2 and 3 are the quantities against the x, y and z axis. Similarly, two vectors can be added and subtracted, and addition and subtraction will be among the respective x axis, y axis and z axis quantities. Dot product of the two vectors is denoted by a dot b, and it will be equal to a mod multiplied by b mod into cos of theta. Theta is the angle between the vector a and b through the smaller side. And if we see in a plane, then there will be a smaller angle and a larger angle between the two vectors. So theta would be taken as the smaller angle between a and b. And similarly, we have defined different vectors along x-axis I, j and k, x-axis, y-axis and z-axis. I is along x-axis, j is along y-axis and k is along z-axis. So I dot I means their scalar product, and j dot j and k dot k will be equal to 1 because both are in the same directions. And I dot j, I is along x-axis and j is along y-axis. The angle between them is 90. So the angle, I dot j is equal to j dot k is equal to k dot I, and this will be equal to 0 because the angle between them is 90. Similarly, their magnitude can be calculated as the mod, and that will be equal to a1 square plus a2 square plus a3 square. Additionally, we can find the distance between the 2 points. Let's say that this is the point P1 and this is the point P2. What is the distance between these points in this space denoted by Cartesian coordinates x, y and z? This will be, if you see that this is the point P1 and this is the point P2, the distance can be measured from P1 to A, and then A to B, and then B to P2. So we can say that P1 to P2 is equal to P1B, that is, this is the point, plus B P2, B and P2. This is the diagonal one, and this is this, and this is. And similarly, P1B will be equal to P1A and P1B. So the entire sum will be P1A from this to this, and then AB, and then B into P1. And these values can be calculated easily as we normally calculate in plane vectors. So P1 will be P1A is equal to x2 minus x1, because this is the xy axis, x-axis, this is the y-axis, and this is the z-axis. X2 minus x1 into I plus y2 minus y1 into j plus z2 minus z1 into k means the distance between this point P1 to P2 can be calculated by just taking a difference or subtracting the respective x's quantities. For example, x2 minus x1 into I, because it is along the x-axis, y2 minus y1 into j, because it is along the y-axis, and z2 minus z1 into k, and because this is along the z-axis. So this will be the distance vector between the point P1 to P2. Okay, then P1 P2 mod will be equal to, definitely we have already learned that taking care of each component vector. So x2 minus x1 whole square plus y2 minus y1 whole square plus z2 minus z1 whole square will result in the magnitude of the vector. Since it is in three-dimensional plane, so the angles between there will be three angles between these vector xy plane and yz plane and xz plane. There will be three different angles for this vector in the space, and we can find the value of these angles in the space between these different x-axis, y-axis and z-axis. Let OA be a vector whose directions are to be found, and these directions are known as the direction cosines of a vector. For example, let A is equal to A1j plus A2j and A3k is a vector making an angle alpha Alpha is the angle between x-axis. So the alpha is the angle from this to this x-axis and this vector. Beta is the angle with this vector and the y-axis, and gamma is the angle between the same vector and the z-axis. So we can say that I dot A is equal to I1 magnitude into A magnitude cos alpha, because it is a dot product. So this will be equal to A mod cos alpha. And similarly, J dot A and K dot A can be calculated because their respective angles are beta and gamma. So Ij dot A is equal to A mod cos beta, and K dot A is equal to A mod cos gamma. And from this we can we will just calculate this value cos of alpha, and this A will go downside I dot A. So I dot A over A, and I dot A will be equal to A1 over A mod. Cos beta is equal to J dot A over A mod, and so like other values are. So these are known as the direction cosines of vector A. And since cos square alpha plus cos square beta plus cos square gamma is equal to 1, so it can be checked easily from this by taking squares of these values and adding. So A1 square plus A2 square plus A3 square divided by whole mod square will be equal to 1. Here comes the concept of unit vector, because these are the cosine of a vector. So the cosine angles along the x-axis, y-axis and z-axis, their values I cos alpha plus j cos beta and k cos gamma is known as a unit vector parallel to A. So it means two vectors A and B in a space will be equal, only will be parallel if their unit vector are same. Their magnitudes may be different, but if their unit vectors are same, then the two vectors will be parallel. Now let's have a few examples. Find the distance of the point P1 to 3 from, first is the origin, second the distance of this point from the x-axis, the distance of this point P1 from the z-axis, distance of point P1 from the xy plane, and distance of point P1 from the other point P2. We have already learned that the distance of a point from the origin is called the position vector. So the origin is normally 0, 0 and 0. So in this case the distance vector R will be equal to OP1. O is for origin and point P1 is that represent 1. I plus 2j plus 3j, and P1 from the origin, which is also known as the position vector, can be calculated as R. R is equal to O into P1. O is for origin and P1 is for point, and that will be equal to I1 plus 2j plus 3k. These are the coefficients of the unit vectors along their respective axes, and so the distance vector will be I plus 2j plus 3k, and the magnitude of this distance vector R can be calculated taking the squares of the individual quantities from the x, y and z axis 1 square plus 2 square plus 3 square, and the resultant will be 14 under the root. Similarly, for the part B, in which we have to determine the distance of the point P1 from the x-axis. So when we talk about the x-axis, it means that this component x value is 0. So AP1, which is the distance from the x-axis, can be written as 2j plus 3k. So this value can be neglected, and 2j plus 3k will be the vector representing the point P1 from the x-axis, and hence its magnitude will be 2 square plus 3 square under the root, and that will be equal to 13. Similarly, we can say that what is the position or what is the distance vector of this point P1 from the z-axis. When we talk about z-axis, so the z component value will be 0 because it is from the z-axis. So the vector will be dp1 and it will be equal to I plus 2j, and I plus 2j, and then if we take the mod for calculating magnitude, it will become 1 square plus 2 square, and the result will be under root 5. The third one is calculate what will be the vector, calculate the magnitude of the distance of the point P1 from the xy plane. When we talk about xy plane, it means that the x component 1 and the y component 2, this will become 0, and the distance of this vector BP1, let's say it's a BP1, is equal to 3k, and its magnitude will be just 3. Now we have to determine the distance between these points, point P1 and P2, that is the part E. These 2 points are in a space. So as we have already seen that their resultant distance between the 2 points or between the 2 vectors in a space can be calculated as the sum of differences between their x-axis, y-axis and z-axis quantities. So the distance vector P1, P2 will be 3 minus 1 into I plus minus 1 minus 2 into j plus 5 minus 3 into k. That will be 3 minus 1, 2i minus 3j and 2 plus 2k. So this will be the vector P1, P2, and its magnitude once again will be the sum of squares and the under root of this value, mod of this value. So 2 square 4 plus 3 square 9 plus 2 square 4, and it will become 17 under the root. Now let's have another example. Here we have to find the angle theta between the vectors joining O to P1 and O to P2. These are the 2 different vectors, position vectors OP1 and OP2. We have to find the angle between them. So in this case, the position vector OP1 can be denoted as I plus 2j plus 3k. Here is, while the vector R2 denoting the point P2 to O1 can be written as 2j minus 3j minus k. That is R2 is equal to 2i minus 3j minus k. And then we can find the angle between them by taking their dot product. So if we say that the dot product of these two vectors r1 into r dot r1 dot r2 will be equal to r1 r2 multiplied by cos theta, and cos theta definitely will be r1 dot r2 divided by r1 into r2 and their magnitude. If we calculate the magnitude of these vectors, that will be 14 under root for both the cases, and r1 dot r2 will be the multiplication of these two vectors with their respective x-axis and y-axis and z-axis quantities. So 1 into 2 plus 2 into minus 3 plus 3 into minus 1, this will be the r1 dot r2, and the resultant will be minus 1 over 2, and cos theta is equal to, when cos theta is equal to minus 1 over 2, then theta will be the value of theta will be equal to 120 degrees. So the angle between these two vectors r1 and r2 originating from origin to point p1 and p2 will be 120 degrees. Now let's have another example. Here in this case we have to determine the angle alpha between the vertices of a triangle ABC, whose vertices has been given as A is equal to 1 0 1, B is equal to 2 minus 1 and 1, and C is equal to minus 2 1 and 0. These are the vertices, these are just the points of a triangle in a space. So in this case we will have to determine this angle alpha. As previously we have seen that we were given the two vectors, and if we have been given two vectors, we can easily determine their dot product, and then cos theta can be determined to measure the angle between these two vectors. So in this case, once again we will first determine A and B, the two vectors, and then the difference between we can calculate the angle alpha between them. So in this case the vector A is between point A and C, so the distance vector can be calculated as the difference of the point C and A. If the point, let's say we see the point C and A, so A will be equal to minus 2 minus 2 minus 2 minus 1, so it will be minus 3i, and 1 minus 0, it will be 1j, and 0 minus 1, it will be minus k. So AC is equal to minus 3i plus j minus k, and the vector B will be the difference between the point B and the point C. So point B and point A and this will be point B is 2 minus 1, point B and point A, this will be 2 minus 1, so it is 1i, and then minus 1 minus 0, that is minus j, and third one is 1 minus 1 0, and k. So the k component in this case will be 0, so AB is equal to I minus j. So we have now determined the two vectors A and B, and then rest is like the previous examples. We will just determine their dot product. A dot cos of alpha will be the dot product divided by A mod, B mod. In this case, A dot B is minus 3 multiplied by 1 plus so the dot product will be the multiplication of the respective quantities, and then adding we will get minus 3 minus 1 and divided by under root 22 A mod and B product of A mod and B mod, and the resultant will be minus 0.85280, and alpha can be determined cos inverse of this value, and that is 148 degrees and 31 minutes. So that is all from my side for the today's lecture. I think you will have a better idea for calculating the position of a point, distance between the 2 points, and a distance vector, and so on, and we can manipulate these values in any way as per our requirement in the problems that will come across in future. So it's okay. Allah Hafiz.